Yes, so the variance using method number 2, we're dealing with group data. The formula for it is in the list of formulas. Here it is. It's similar to the raw data, but the only difference, you have F. F is present. N is the sum of F. So N is replaced by the sum of F. The sum of the frequencies F is N. Okay, so let's just take a snapshot of this formula. And on the right side now, the square root of the variance, here's the variance inside of the square root sign, will give you the standard deviation. And that's what we eventually want, the standard deviation, meaning by how much the values deviate from each other. There's another word again for difference, deviate. Okay, that's where you have the subtraction sign present in the formula. The average deviation amongst the values. Okay, if you want to put it that way. Now, when we look at this formula, we know the sum of F is already 70. The mean is 78.83 in this example. Let's carry it forward. No, 42.21, sorry, 78.83 was the scores, 42.21 centimeters. Okay. And when we look at the formula, we see sigma again, but we are accustomed with sigma, so sigma cannot do us anything now. Okay. Whenever we see sigma, we are very comfortable with sigma because we know exactly how to deal with sigma. Whenever you see sigma, ignore sigma. Okay. You might have, because I normally see sigma in certain economics formulas, accounting formulas where you have to sum. Whenever you have to sum, sigma is present, and sometimes coming with little things on top and below it. Whenever you see it, don't make it confused. You say sigma, just ignore sigma and focus on what is to the right of sigma and leave sigma for last. Okay, so in the future, whenever you see sigma, ignore sigma, focus on what is to the right of sigma, do that, and then apply sigma. Please remember that. Okay, so we have to do fx squared. Fx squared, we have to do fx squared. We have to make a table called fx squared. Here it is. Okay, create a column labeled fx squared. Here it is, fx squared. Okay, what are the fx squareds? Look, the fx squareds. The f's are the data values. The f are the frequencies, sorry. The x are the data values. Okay. The first fx squared is actually 8 times 10 squared. Also by Microsoft Word, so I can use this superscript. I can use the home squared. Okay. Click on it. Equal. That's the first fx squared. Okay, we have to do the fx squared before we sum. The next fx squared, so let's just copy this. The next fx squared is 20, because 20 is the next f, here it is. And the next x is 22.5. 22.5 squared. What's the next fx squared? 30 times 37.5 squared. The next fx squared is 12 times 50 squared. So these are the fx squared. And you want to do an fx squared manually, you go to your calculator. You type 8 times 10 raised to the power of 2. Okay. And please bear in mind, fx squared means it's the x alone that's being squared, because this brings to mind historically, a lot of students want to square the fx. A lot of students, very commonly every semester, and if you want to apply this formula, okay, where we have the fx's, they would go back to the mean and they would square the fx's, square the 80, square the 450, square the 1125, square the 600, because of the misinterpretation of fx squared. Fx squared means it's only the x that's being squared. Fx squared. If the f was to be squared too, then there would have been a bracket, fx squared, all squared. But it's not fx all squared, it's fx squared. Okay. So therefore now, fx squared is equal to f times x times x. It's only the x that's being squared. Okay, bear that in mind. So another way to put fx squared is 80 times 10 times 10 is only the x that's being squared. Manually, you'll get 800. Okay. However, why do this manually when we have Excel there to help us out? We can just delete this, leave the sum there because we're going to use the sum. Fx squared a1 equal, sorry, forget to put the equal a1. All right, that's f. X is b1 all squared, fx squared, 800. So the first one we got 800 manually, 800, you know. Just go to your green rectangle, and here you have it, and you have your auto sum, copy, and paste. Okay, we don't know further on. And here we have our sum of our fx squared. That is this part of the formula, right? So we can come and click enter and go to insert, go to equations. Variance is equal to, variance is S. We want for a little square, we go to script, superscript. Variance is equal to the sum of fx squared. Here is the sum of x squared, here it is. We found the fx squared first, and then we find the sum thereof, divided by the sum of f, which is 70, subtract the mean squared. The mean is 32.21. That's it. Okay, let me just, oh, I could recall if you put shift shift 6 and put the square in it, it automatically put in the superscript. Okay, so that's another way to get superscript quickly. You don't really have to go and look for it. You can just press shift 6 and just press tab and it automatically puts it. Okay, let's verify if that's the mean. So the more you 42.21, the more you play, if you want to, for want of a better word, with the, you know, with the app, of the device, the more skill you become with it, the more you interact with it, you discover new things, which is a skill you can use, you know, in the future. So please be able to put this as is in your calculator and just press enter 149.84. Okay, compare it with the first method. We'll do that in a while. 149.84, and we want to find the standard deviation. The standard deviation is the square root of the variance. The variance we call it to be 149.84 approximately. Control C, Control V. Equal. Back to the calculator. Control C, square root, Control V, enter, 12.24 centimeters. Okay. And we can delete this. Therefore, average variability, that's another word for dispersion, amongst the heights is 12.24 centimeters, full stop. Okay. Variance and standard deviation using method 2.